So what is the percentage composition of a compound? And how can you be able to express much about the percentage composition of a compound? And for you to understand about the percentage composition of a compound, let's have this kind of the way out. Let's say we have 3 stones. Let's say this is a stone 1. Let's say it is of, let's say stone 1, which is given as which is of mass 1. Let's say it is given as 2 kgs. And we have another stone, let's say stone 2, with mass given as, let's say M2. And say it is given as 5 kgs. And we have another stone, let's say a stone 3, with mass given as M3. Let's say given as, and that should be 4 kgs. So now the point of interest can be, what is the percentage of mass each actually a stone is contributing? So you see that for you to have the percentage mass actually each stone is contributing, or have it as percentage of mass each stone is contributing, will be given as the mass of that particular stone, the mass of that particular stone divided by the total mass. So this actually times 100%. That will be the percentage mass each stone is contributing. And for instance, let's say we are looking for the percentage in which the M1 is contributing, or have the percentage that is, let's say for the mass M1 will be given as, what is the mass of the stone 1, or have it as 2, and what is the total mass, or have it as, it should be, now have it as 11, and it times 100%. So times 100%, that will be given as, so what is that? And of which you have it as this. So now which means we'll have, 2 times 100, so it should be 2 times 100, and divide by 11. Now should be divided by 11. That is given as, now should be, we have it as 18 point, let's say 18%. So this is the percentage of the mass in which the M1 is contributing, and in the correction of the 3 masses. And likewise, we can also have the percentage mass and for the mass of object 2. That will be given as, what is the mass for object 2? We have it as 5. And then divide by the total, which is given as, now should be, what is the overall total of the mass, by the way? We have this as 4, and this is 5, which is given as 9, and 9 plus 1 is given as 11. So this is true. So now what is the percentage mass for the object 2? We'll have 5 divided by 11 times 100%. So you'll be able to have the percentage mass the actually object 2 is contributing towards the total mass of the 3 objects. So that's how you should have to understand that and up to. So now with this context, what is the percentage composition of a compound? Now whenever we are saying whenever we are talking about the percentage composition of the compound, the essence behind it is to look at the given actually compound. We are to look at the mass each element is contributing in terms of the percentage in that particular compound. Let's say we have the compound of water given as H2O. So this is the compound of water consists with hydrogen as well as the oxygen. And mind you, each element is having its actually atomic mass. So what is the percentage of the mass each element is contributing to the overall mass of the compound? So that's the essence behind the percentage composition of a compound, where we are to look at the mass in which each element is contributing in terms of the percentage in the compound. So now, how should we be able to have the percentage composition of a compound in this case? Let's say we have a compound that consists with the elements like A, B, as well as the C. Let's say this is the typical compound. Now, let's say given this particular compound, and we have the relative formula mass of the compound. Let's say it is should be relative formula mass of a compound. It is given as RFM. Let's say we should have it as ABC, meaning relative formula mass of the compound that we have is equal to, let's say the relative formula mass of a compound, it is given as B. Let's say that's the case. And in this case, let's say we'd like to have the percentage composition of, let's say, element A. What will be that? We use the formula that says that relative formula mass of a compound, let's say for this case, a compound ABC divided by, now it should be this. We'll have, let's say we'd like to have the percentage composition of an element A. So which means we'll have relative formula mass of an element A divided by, now should be RFM, which is the relative formula mass of the compound which is given as ABC, and the times 100%. So this is the formula we can have to use. And for instance, which means we'll have it as, let's say the relative formula mass of, let's say, a particular compound should be an element. It is given as, let's say, a D. It means we'll have the total relative formula mass of a compound given as, let's say, B, in the times 100%. That is, and for instance, let's say the relative formula mass of B, of an element B, let's say it is given as M, which means we'll have M divided by the total relative formula mass of a compound times 100%. Let's say the relative formula mass of an element C, it is given as, let's say, N, which means we have N divided by the total relative formula mass of a compound times 100%. So that's how we go for the relative, should be the percentage composition of a compound. Now let's say we have a compound given as, let's say, let's say, carbon dioxide. So what is the percentage composition of the compound? In other words, we should have to look for the percentage composition of each element in the compound. So in this case, we should have to calculate the RFM of the compound, that is CO2. We should calculate the relative formula mass of a compound, carbon dioxide. We'll have it as RFM of CO2. RFM of CO2. That will be given as that. Now, how should you have the relative formula mass? So now in this case, the same way we used to have the relative formula mass of a compound, it is the same way we should have to go for this. So how many carbon atoms are in a compound? We have it as 1. In the times, what is the lam for carbon? And of which the lam for carbon is given as 12. We'll have it as 12.01. And this is basically for high school. Should be basically for college or university, and also part of some high schools. Of course, in a secondary school, it is actually 12, which is used for the lam of the carbon. So that is for the secondary school students, where they use 12 instead of 12.01. So keep that in mind. So if you are a secondary school student, you'll be using 12 instead of 12.7. But this is, let's say, for a college, university, or some sort of high schools, use this. So in that case, a plus. And what is the lam for oxygen? We have 2 oxygen atoms. Times, what is the lam for oxygen? We have it as 15.99. And for the secondary students, we have it as 16. That is the lam for the oxygen. So keep that in mind. Then how should we have the RFM for the compound. So which means we'll have 12. So that is, we'll have it as 12. And at 0.01 in the price. What is should be 2 times 15.99? So 2 times 15.99, we'll have it as 31.98. So we have it as, so we'll have it as 31.998. And basically it is giving us atomic mass unit. So what is that? In the price 12.0. That is giving us 44.008 atomic mass unit. So that is the relative formula mass of a compound that we have. The next, we should have the percentage composition of each element. Let's start with the percentage composition, let's say, of a carbon. Now that one will be giving us, what is the relative formula mass of a carbon? We have it as a 12. We have it as a 12.01 divided by what is the total? We have it as 44.008. That should be times 100%. And with this case, we'll have it as this. So which means we'll have it as, now we'll have, that should be 12.01 and that times 100%. That will be given as 27 point, let's say, 3%. So this is the percentage composition of actually oxygen. Should be a carbon in the compound. Then you can proceed for oxygen, as you'll be able to have it okay in that way. Let's say we have another compound. Let's say we have the sodium hydroxide as a compound. Now, what is the percentage composition of a compound in this case? So now, first thing, you have to calculate the RFM of the compound. And what is that? We have, what is the, how many atoms for sodium are in the compound? We have it as 1, so have 1 times, what is the lamp for sodium? So we have it as 22.22 22.99. That should be a 97. That is for the ecology students. But at secondary school, we have it as 23. That is the lamp for active sodium. Let's now have it as a plus, then plus, and we have the only single oxygen that is given as 1 times 15.999, and plus, what about the actually for the hydrogen? We have 1 times, now have it as 1.00, and that should be 8. So it should be 1.008. And at the end of the day, we'll have it as atomic mass unit. Then from there, you'll be able to have the relative formula mass of a compound in that way. So which means we'll have 1 times this, that will be given as 22. .9997, and the plus should be 15.999 plus, then you have 1.00, and that should be 8. So we'll have the sum of those. So 22 the 0.9997 plus to have 15.999 the plus 1.008, and of which you have it as 40.0067. that is atomic mass unit. So that is the relative formula mass of a compound. The next we'll have the percentage composition of each element. Let's start with the percentage composition, that is for the sodium. That will be given as, and of which we'll have the mass of the sodium, which is given as 22.9997 divided by the total, which is given as 40.0067 in times 100%. Then you'll be able to have the percentage composition of the sodium. And do the same with that of, and that should be oxygen as well as the hydrogen. So principle remains the same. Now the knowledge of the percentage composition can also help us in different ways. And we can be able to know the ratio of the mass in the for a given compound. Let's say we have, let's say H2O. Let's say this is the case. And we have, let's say, 100 grams of water. Now, how can we be able to have the mass of hydrogen in 100 grams of water? And also, how can we be able to know the mass of the hydrogen in 100 grams of water? And let's say we have the sodium hydroxide as we had it before. Now, let's say we have 500 grams of sodium hydroxide. How can we be able to know the mass of the sodium in 500 grams of sodium hydroxide? How can we know the share of the oxygen in 500 grams of hydrogen, sodium hydroxide? And how can we know the mass of the actual hydrogen in 500 grams of hydrogen? Should be sodium hydroxide. So that's the basic application of the percentage composition. Now that we know the percentage composition, how can we know the mass of an element of a compound given the typical mass? Let's say we have the mass of, let's say we have the sodium hydroxide like this, and we have this actual mass. How can we have the mass of sodium in 500 grams of, let's say, sodium hydroxide? Now the formula for the mass, let's say a mass of a sodium, will be given as the percentage composition of the sodium in the times the given mass. We'll have this as the formula. And say we have the following cases. Let's say we have that of, let's think of having something else. Let's say we have HCl. In this case, I should say we have, let's say, 20 grams of HCl. What is the mass of hydrogen in 20 grams of HCl? And what is the mass of, let's say, chlorine in 20 grams of HCl? How can you do that? So now first thing, we'll have the percentage composition of hydrogen and also the percentage composition of actually a chlorine. Then we'll have to multiply the percentage compositions. With respect to that, we'll be able to have the mass of each element in the compound. So let's start it up. We should have the relative formula mass of a compound. That is, now have 1 times, what is the lamp for hydrogen? We'll have it as 1.008. And this is for the college or university students or some sort of high schools. But for the secondary students, we use that one. We use it as 1 for the lamp of hydrogen. And I'll have it as plus. And we go for chlorine. We'll have it as 1 times. What is the relative formula mass? Should be, what is the lamp for a chlorine? So you have it as 35.453. So 35 we'll have it as 35.453. But for the Sunday school students, we have it as 35, representing the lamp for chlorine. In that case, we'll have it as, have 1.008, that is upon having 1 times this. And plus, we also have 35.453, representing the mass of chlorine. 35 point should be 453. So that is, will be given in atomic mass unit. And what is that if we tend to add? So we have 35.453 should be 1.008 plus 35.453. That is given as 36. We'll have it as 36. We'll have it as 36.461. That is the relative formula mass of a compound. The next, we should have the percentage composition, let's say, for hydrogen. Now in this case, we'll have the mass of a hydrogen, which is given as 1.008 upon having 1 times this, divided by the total, which is given as 36. Should be 36.461 in times 100%. And we'll have it as so have 2.76%. So this is the percentage composition of the hydrogen. The next, for us to have the mass of the hydrogen in our 20 grams, which means we'll have it as, we'll have the mass of the hydrogen is equal to 2.76% times 20 grams. So that one will be given as that, of which you have 2.76 divided by 100 corresponding to that, then times 20 grams. You'll be able to have the mass of the hydrogen 20 grams, and this is true for all elements. And you try to compare that one and for the other actual element as well, that is chlorine. That's how you should have to understand about the percentage composition, on how we can be able to make use of it. In this case, you should have to get it. So which means if we know the mass each actually element will have, then we can be able to have the number of atoms as well. On the same case, we know that if we have HCl, about 20 grams, and if we have the mass of the mass of hydrogen, as we have already done it, and if we know the mass of chlorine, as it has already been done, then you can be able to have the number of moles of chlorine should be of a hydrogen in 20 grams and also the number of moles of chlorine in 20 grams upon having the mass of each actual element, using the formula for the number of moles, which is given as the actual mass of molar mass, of which the mass it is the one that was already been calculated. Then you'll be able to have the number of moles. And on the same case, you can also be able to have the number of particles using the formula which is given as the number of particles is equal to, should be the Avogadro's number, in that terms the number of moles. So which means the number of moles should be the number of particles can be calculated using this formula, where we have the number of particles, that is Avogadro's number rather, and this is the actually, and this is, and that should be the number of moles. So which means if you have the number of moles, you can be able to have the number of particles using this formula. So there are more you have to understand about the percentage composition of a compound in that case. So here's the task for you. Find the percentage composition of each element in sulfuric acid. Let's say H3, H3P, SO2, SO4. What is the percentage composition of each element in this? Then find the mass of each element in 60 grams of the sulfuric acid. And from there, to have the number of moles each element is having, and also the number of particles each element is having in 60 grams of sulfuric acid. So thank you for now. But this knowledge will also be very important when we'll be looking at the aspects of the empirical formula. You'll be able to see what is an empirical formula and also molecular formulas about. But this is the very important basic knowledge you have to keep in mind. Thank you.